Hello students, and welcome to section 8-4 continued. Use inverse trigonometric ratios. You can use a calculator and the sine, cosine, or tangent to find the measure of the angle, called the inverse of the trigonometric ratio. Example, use a calculator to find the measure of angle t to the nearest tenth. The measures given are those of the leg opposite angle t and the hypotenuse. So we're going to write an equation using the sine ratio. So if we look at the picture, like we did in the prior discussion at the beginning of 8-4, I'm going to circle angle t. And because we want to find using the opposite side, which is here, to t, 29, and the hypotenuse to t, okay, the adjacent side is st, but we're not going to be using that in this particular context. To find angle t, we can use the opposite side and the hypotenuse, because as we remember, the sine of t, as Sohcahtoa helped us remember, sine of t is equal to opposite over hypotenuse. In other words, the sine of t is equal to 29 over 34. Now that's great, we know our ratio. However, we don't quite have a technique or strategy yet to find the angle. So what we use is something called an inverse. So this little symbol right here, which technically we've seen before but in a different context, this notation and symbol for that matter is going to be indicative of what we need to do to find t. And this again is the inverse. Okay. In the past, when we dealt with inverses, we were looking at inverse functions, which in a sense is still the same thing, but for our purposes here, it's the inverse of what we're looking at as a ratio by virtue of taking on your calculator the inverse ratio and in turn get the angle. So I'm going to go ahead and type in mode on my calculator just to double check that I'm in degree mode. And then I'm going to go ahead and quite literally hit second sine. We're going to use the inverse sine feature. And then we'll go ahead and type in the fraction, 29 over 34. And when we're ready, I'll go ahead and hit enter. The calculator has the ability to take that ratio and interpret the angle of which has to create it. In other words, 58.5 degrees. So the inverse trig ratio of sine in this case gives us that particular quantity. Now, in order to check your answer, you can actually just simply do sine of the answer. And if you do sine of the answer, now you're not going to know what this decimal is certainly, but I'm going to go ahead and just confirm that if you use math, convert to fraction, it ends up, of course, it should at least be that particular fraction, 29/34. So it is true that the sine of 58.5330237 is 29 over 34. It's a nice way to check your final answer there. So I'll continue. We've got some problems obviously below here, which are going to utilize for finding t, a variety of functions. So I'll go ahead and circle number 1. And because we're finding the measure of t, we look at what's provided. And as you can tell in the picture, you've got the opposite side. And in this case, you actually have the adjacent side. So you don't have hypotenuse in this case. And I'm going to go ahead and refresh our memories on Sohcahtoa yet again. Recall that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So for this particular problem, we have opposite and we have adjacent. There's no other option here besides tangent. Again, we want the tangent of t, and that is going to be equal to opposite 14 root 3 over adjacent 34. Okay, so to find t, we'll be able to then say on our calculators here in a moment what the inverse tangent of that ratio is as a decimal. We'll be able to see that. Now you cannot do this without a calculator. So let's get the calculator going here. And if we do inverse tangent and 14 square root 3 divided by 34. our angle should end up as such, 35.49. If they ask you to round to the nearest tenth, I would argue that 35.5 is an accurate or decent depiction of this. So 35.5 degrees. Okay, let's continue. So we've done sine in the example. We just did tangent. We should probably take a look at cosine. So a good example of which is number 4. If I circle the angle that I'm trying to find, in this case, t again, knowing that I have the adjacent side, and I also have the hypotenuse again, we can go ahead and use, well, again, with Sohcahtoa in mind, we have adjacent A, and we have hypotenuse H. So cosine of t should be equal to adjacent 32 over hypotenuse 101. So again, the t value can be assessed using the calculator using the inverse cosine of the ratio. Let's see what we end up with. Inverse cosine of 32, so second cosine of 32 over 101. And in fact, you get the angle to be 71.5 degrees. 71.5 degrees. All right, I'm going to use this problem as a kind of finishing touch, so to speak, to where we can do extra analyses, particularly if I had asked you guys, knowing what t is now, you could actually find r. Let's think about this. Angle r, without even using trig, we can take 180 minus the sum of 90 and the answer that I just got. Okay? And in fact, you'll end up with 18.5. Okay, so let's jot that down, 18.5. Okay. But let's try also possibly using a trig ratio, particularly, well, if we're remembering, hopefully, that the cosine of t is equal also to the sine of the complement, which in this case would be r. We should be able to find r just as easily, but instead of course, inverse cosine, we're going to use inverse sine. So this is a proof, so to speak, that r can be calculated not just by virtue of subtracting the sum of the angles from 180, but also by doing inverse sine of what? Opposite of r is 32, and a hypotenuse again is 101. So on your calculator, yet again, let's prove, we already know the answer is 18.5. Well, let's prove that the inverse sine of 32 over 101 is again another option for us. If we do that, and certainly you see there, of course, 18.5 degrees. And the decimal isn't even off by a little bit. It's the exact same thing. So 18.5 as I'm rounding as my final answer required. And there you have it. Okay. So that concludes our lesson. I do urge you, though, to take a look at those other problems and apply various trig functions in context, and even attempt, like I did with angle r, an opposing or opposite function, of which would be, in this case, from cosine to sine.